Greetings, peeps. Last in the series of conversions, we're going to do unit conversions of higher order dimensions. We're looking at area and volume in that case. They are higher order in terms of length, okay? So the situation we have here is as follows. We have a square, and let's say it's 1 meter by 1 meter. Width is 1 meter, height is 1 meter, and so we want to determine how many little centimeters square will fit in there. How many tiny little squares that are centimeters will fit inside 1 meter squared? And the answer isn't quite obvious. We want to go through the process. It's not just a direct conversion of, oh, it's got to be 100 because there are 100 centimeters in 1 meter. It's really not that. So let's go ahead and actually do it using our train tracks and dimensional analysis techniques. So we're going to start off with our 1 meter squared, like so. And I'm going to train track that. And here's what we know. We know that there's an equivalence between meters and centimeters. I'm going to put meters down here. Centi is a metric prefix that means 10 to the negative second. So I'm going to put that down over here. So 10 to the negative second meters is the same thing as 1 centimeter. The problem is that we can't cancel anything quite yet. And the reason is because we have meters squared up here in the numerator, and we only have meters here in the denominator. And it's not going to really help us out. We want to be able to cancel meter squared, numerator, meter squared, denominator. So here's what we can do. We could square this term here. If we square both numerator and denominator, then we're all set. That will totally work for us because that would be an equivalence as well. So if I square this and square this, we've got to take care of some of the math in order to figure this out. So now when I do this, I get 10, negative 2, and raised to the negative 2. We multiply exponents, so it's 10 to the negative 4th, and now I also square the unit, 10 to the negative 4th meters squared. Up here I get centimeter squared, 1 centimeter squared, because 1 squared is 1. And so what I have here is a pretty awesome cancellation of meter squared and meter squared, leaving us the unit we want. So 1 divided by 10 to the negative 4th is the same thing as multiplying by 10 to the 4th. 10 to the 4th is 10,000. So what we actually have here is not 100, but 100 squared. And that's 10,000 centimeters squared. It'll work the same for cubes, but you have to take into account the cubing as the equivalence instead of the square. And if you go into the 4th dimension, please show me how you do that. Morad out.